All right, and taking a look at the first one, I think that you're right. You square this stuff, and when you FOIL it out, you get that middle term false, yeah. This next one, well, you just did it here, so one side's equal to the other side looks good. I'm not sure what you were doing with this here. I'm not really sure how you could prove that one side is equal to the other side. I guess what you could do is multiply this one on this side by an x, so you get an x up top. So if you multiply both sides by an x, then on the right side you get x over x times y, but on the left side you have x over x plus y, so it's false. Another way you could do that one is just plug numbers in. So plug, say x is 1 and y is 2, plug them in and see if one side's equal to the other side. This one, the dirty negative, you figured that, that's good. This one, the absolute value sign, it's sort of a funny one, and in math we often skip over this. The book usually looks at that. But if you have a number, so say you've got this, and you want to know if that's the same thing as just basically x. The one thing you know is you have to, whatever's under the square root can't be a negative. But if it's squared, maybe it could be a negative. I wonder if that would be right. So say if I take a negative 9, for example. So if I take a negative 9 and square it, then negative 9 squared is the square root of 81, and the square root of 81 is 9. And so I guess that doesn't work, does it? Because they say it's just equal to x, but in this case, I initially plugged in a negative 9 for x, right? And the answer that I came out to in the end is a positive 9, so they didn't come out to be the same. So when you square something, that's something that, I hesitate with that one. I guess I just proved it by plugging in a negative 9 in, it doesn't work. So I wonder if this one works then. Let's try another number with that one. So we've got the square root of x squared is equal to the absolute value of x. So let's plug in, say, a 2. So for x is equal to 2. No, let's do 4 because you can get square root of it. Well, I guess it doesn't matter because it's squared in there anyway. So 4 squared, and that would be the square root of 16, which is just basically 4. And on this side, I have to take the absolute value of what I plug in for x, and that comes out to 4. They both check. So let's try a negative number. So let's try a negative 3 squared. And is that equal to the absolute value of negative 3? That's our question. So negative 3 squared would be a positive 9, and the square root of 9 is a 3, and the absolute value of negative 3 is also a positive 3. So this one here, I would be saying true for that one. And this one here, I'd be saying false. Because we proved that right here, that when I plugged in a negative 9, the answer on the other side doesn't come out to a negative. Okay, hopefully that helps there. This one, I think you were right there that you can't factor that. It doesn't come out to x plus 2. So you're right with that one. This one, I don't know about that one. I think it's similar to that number 3 that we did up there. So are those two things the same? And I guess you could plug numbers in to see. Plug a 2 in for x and a 3 in for y. Let's do that. So 1 over 2 plus 3, is that equal to 1 over 2 plus 1 over 3? So here I can just add those, so that'd be 1/5. But is 1/2 plus 1/3 equal to a fifth? I don't think so. You'd have to get a common denominator. So 3, 6 plus 2, 6, you'd get 5, 6 on the left side, whereas on the right side you get 1/5. So this number 8, not that one's false. I'm just thinking of another way you could do that. Like here, you could work with one side or another side. So they give you 1 over x plus y, and it's equal to 1 over x plus 1 over y. Well, you could add these fractions, right? But to add the fractions, you need to get a common denominator, which would be xy. And then to this first one, you have to multiply y on the bottom, so it'd be y times 1 or y. And the second would be this. And so now I have a common denominator, so it'd be x plus y over xy. And I look at the other side, and that's not what they have. So, yeah, I'm just trying to think of another way I could. I'm not sure of another way that I could get the same denominator even. Yeah. Anyway, hopefully that helps you a little bit. This one, getting a common denominator and simplifying and see what you come up with, and they're not the same. Or, like I said, you can plug numbers in, like I did here, and see if one side's equal to the other side. Okay, hopefully that helps.